Hi guys, and welcome to Learn Extra Live. It is grade 10 maths, the very first show of the year, and we have Natasha with us. How are you?
I'm great. It's fantastic to be back and really excited to get 2013 rolling.
I can't believe it. I cannot believe
I
it.
know.
We were saying, and this is our first show, guys. We are so excited to be spending it with you, and I hope that you are all tuning in. And we were talking earlier, Natasha, if they start right now, grade 10, and they work really, really hard, by the time they get to grade 11 and grade 12, it'll be plain sailing.
Absolutely. I mean, grade 10 is the foundation phase, really, that sets things going for grade 11 and 12. So you get a good grounding in grade 10, and grade 11 and 12 will be not a breeze, but hopefully a lot simpler.
And in grade 11s and grade 12s, if you guys do want to be watching this, scratching up on their knowledge.
Revising.
Yes, exactly. We're going over algebraic expressions, products, and factors.
That's it.
That is it. So, Natasha, go and take your spot
Thanks
by
so
the
much.
board. Let's see if I remember how to do this, guys. Of course I do. Guys, tune into facebook.com/Learn Extra. You can also chat to us on Twitter @Learn Extra. If there's anything that we're going over that you don't understand, please post it onto the Facebook page, and we are here to help you every single step of the way. I do know there are a lot of people joining in. Mindsetters, it's so nice to see you, and we've missed you terribly. I just want to read this from Mpundulo. And mindset. It says, life is an adventure experienced in all stages. Today's lemons are the ingredients for tomorrow's lemonade, which I think is amazing. So now let's get straight to the lesson. Natasha, take it away.
All right, guys, and welcome to your first lesson for the year, the first live show. It is really good to be back with all of you, and hope you've got your pens, papers, notebooks, calculators, whatever you need ready. Grade 10s, we're going to start by doing a little bit of revision, just easing you back into algebra at school. And for a lot of you, this might seem really simple because, as I say, a lot of it is revision, and we will tackle one or two new grade 10 concepts as well. But the most important thing in maths is you need to have a good grounding, you need to have a good foundation so that you can do the harder stuff. So you need to know the simple stuff so that the harder stuff seems easier. Okay, so we're going to get straight into it. We're looking at factors and we're looking at products. First, we're going to start off with a quick recap on products and go over a few basic terms that you need to know, and later on we will be looking at factors. Okay, so in this lesson, we're going to look at how to expand an algebraic expression. Now remember, an algebraic expression is made up of terms. And terms are separated by pluses and minuses. So we're going to look at how to expand an algebraic expression by multiplication. We're going to look at timesing a binomial or a trinomial by a single term. Now before we look at doing that, we need to understand what a binomial is, what a trinomial is. Remember, a binomial has two terms. So, for example, A plus B would be a binomial. A trinomial, like tricycle, if you think of your three wheels, tricycle, trinomial, it means something with three. In terms of algebra, when we're talking about a trinomial, we mean three terms. All right, so for example, A plus B plus C, that is an example of a trinomial. Obviously, a single term or a monomial would just be, for example, the A by itself or the B by itself. Okay, we're also going to look at multiplication, multiplying a binomial by a binomial by a trinomial, so two terms by three terms. And when we go on a little bit later on in the lesson, we're going to look at factorizing. Remember that factorizing is the inverse process of products. So with products, you're timesing your brackets out, you're getting lots and lots of terms. With factorizing, you're going in the opposite direction. Okay, with factorizing, we want to get to a point where we have single terms and we can't go any further from there. So factorizing algebraic expressions, we're going to look at the different ways we can factorize. The one way is by finding a common factor or a highest common factor, which we normally, and you would hear this at school, we call it an HCF, a highest common factor. We're also going to look at factorizing by looking at a difference of two squares. And we're going to look at trinomials and the sum and difference of cubes, and then also a little bit of grouping. Now guys, what I should point out is you have these notes. Obviously time is not always on our sides. We're not going to be able to do every single example you see in these notes. So some of them you will hear me say, I'm going to do this one with you, and it's up to you to try the other one at home. Okay, so we're not going to go through every single example. Once you have the basic idea, you can do the other one at home. Okay, so whichever other one I haven't done. All right, so let's move on. We're going to look at a product. Now remember that a product, hopefully you guys remember what products are. A product you get when you have two or more numbers and you multiply them together. So for example, just a really easy example, if I have 2 times 3, multiply it together, my answer is 6. So the product of 2 and 3 is 6. Okay, so just some basic revision, basic terms. All right, and in your laws of multiplication, guys, we've got 3 very, very important concepts, which a lot of the time you don't really think of because you just know it in your head intuitively, and you don't really think of the names of them. Okay, but it'll make sense once we have a look at an example and you've seen it before, it'll make sense to you. All right, so one of the important laws is commutative law or commutative law, and what it is we're basically saying that the order of multiplication does not matter. So for example, if I take 5 and I multiply it by 4, my answer would be 20. All right? And if I took 4 and multiplied it by 5, my answer would still be 20. Okay, so what the commutative law tells us is that it doesn't matter when you're multiplying if you say 5 times 4 or 4 times 5, because you're going to get exactly the same answer. So similarly, remember here we're just looking at numbers, but it works in the same way with letters. If I have 8 times B, that's exactly the same as B times A. All right, but as I said, a lot of you will just know this and you do it even though you don't know its name. All right. The next thing we're going to look at is the associative law. All right, and what that tells us is that when more than 2 terms are multiplied together, the order in which you multiply does not matter. So very similar to the commutative, but what we're doing here is we've got more than 2 terms. So if I have 2 times 3 times 4, for example, 2 times 3 is 6, 6 times 4 is 24. Okay, I could have done this in any order. Because we're dealing with multiplication, the associative law applies, you would always get the same answer. So for example, if you took any order, so if I did 3 times 4 times 2, as long as the numbers are the same and they're being multiplied, you're going to get exactly the same answer. All right. And then possibly the most important one for you guys to remember when we deal with products is the distributive law. Okay, now what this law tells us is what happens when we add or subtract and multiply numbers or algebraic terms together in one expression. Okay, so the distributive law tells us how to, for example, tackle an example like 4 times 3 plus 5. Now guys, there's 2 ways you could do this, all right? We're dealing with basic numbers, and some of you might already see it, and you'd be able to do it quite easily just using addition and then multiplication. But the one way we could do this is we could say, well, let's add the numbers together inside the bracket. So keep the 4 outside. Okay, and then 3 plus 5 inside the bracket would give us 8. Okay, we could then multiply 4 by 8 to get an answer of 32. Okay, so that's one way we could do this example. We could first add the numbers together, all right, or add the terms. Remember, even those are just numbers, those are terms. They're separated by a plus sign. You could add the terms together. 3 plus 5 would give us 8, and then multiply the 4 into the 8, and you get 32. Now, the other way we could do it is using the distributive law. Okay, so what that means is that we could work out the answer to this sum by multiplying the 4 by every term inside the bracket. In other words, we distribute the 4 to every term inside the bracket. So, if I do that, this is what I'm saying. We're going to say 4 times the first term, which is 3. All right. Then we've got plus 4 times the second term, which is 5. All right. We know that 4 times 3 is 12, plus 4 times 5 is 20, and 20 plus 12 is 32. So exactly the same as we got before, but the only difference is this time we use the distributive law. So we multiplied the 4 by every term inside the brackets. All right, so as I said, a lot of you do this anyway, but you often forget what it's called. This distributive law is very, very important because you need it when we're dealing with a binomial times a binomial or binomial times trinomials, where it can become quite complex and quite long, but you need to know this basic concept. Okay, so when you distribute, you're multiplying each term inside the bracket by the number outside the brackets. All right. Okay, so we're going to look at some of the key concepts when we are applying the distributive law to algebraic expressions. So we looked at it with just basic numbers, okay? But you know, in grade 10, you don't just get given 4s and 5s and 3s and that. You get given algebraic expressions with unknown values, with variables. You get given x's and 2x's and all the rest of it. So we're going to, after we take a quick break, we're going to have a look at multiplying a binomial by just a single term outside the brackets. And I'm quickly going to hand over to Indy.
Okay, guys, I'm so glad that there's so many of you are tuning in. We're having such an awesome time. Please let us know if there's anything that Natasha has gone over that you don't understand. Post the questions on the page. That's facebook.com/learnextra. Or you can tweet us at learnextra, and we will go over your questions and help you out. So now, grab yourself a glass of water, and we'll see you after the break. Hi guys, and welcome back. I hope that you're all enjoying the show and having tons of fun as much as I am. Chabalala says, yeah, finally you guys are back. I'm so happy. So what time is grade 11 maths? You guys help me to pass grade 10. Mindsetter, grade 11 maths is straight after this, starting from 5 to 6, and then matrics will be from 6 to 7, so stay tuned. So now, Natasha and I were just talking about something that we have to bring up. Bafana have made it through to the quarterfinals. We are so happy, and we want to say congrats to you guys, and we are behind you all the way for AFCON, and we'll be watching as you hopefully take the cup. But before I get sidetracked on soccer, as much as we love soccer, I think it's time to get onto a little bit of maths. Natasha, take it away.
All right, thank you so much, Indy, and welcome back from the break, guys. So as we were saying before that little break, we're going to now look at multiplying a monomial, which is one term, by a binomial. Okay? So remember, a binomial, once again, means two terms. So if I look at this question, 2 times x minus 3, the binomial is obviously inside the bracket, and then your single term or your monomial is outside the bracket. It's just one term. Okay, so we're going to apply the distributive law to 2 times x minus 3. All right, so applying exactly what we learned above when we were just looking at numbers, we're going to times the 2 by every term inside the bracket. So we're going to get 2 times x, okay, so I'm saying 2 times x, and then for the second term we're going to have minus, a plus times a minus. Remember your integers here, very, very important. A positive 2 times a negative 3 is a negative sum answer, and we're going to get that answer by saying negative 2 times 3. All right, so let's go through that again. We've multiplied the 2 outside by every term inside the bracket. 2 times x will just give us 2x x. And again, remember your signs. Minus 2 times positive 3 is negative. Minus times a plus is a negative. 2 times 3 is 6. Okay, so a nice simple example to kick things off there. The next one we're going to look at, and I'm going to do this one even though it's very similar to the one above, simply because we now have a term that doesn't just have a number. We're now looking at variables, all right? So exactly the same rule will apply. We're going to multiply the a to every term inside the bracket. Okay, so a times b. And I'm going to go a little bit quicker now because I think you guys have the idea. A times B is going to give me AB. Positive A times positive 3 will give me positive 3A. All right. Okay. And the next thing we're going to look at is multiplying a trinomial by a single term. Remember, trinomial means 3 terms. So we've got 3 terms inside the bracket. We're going to times it by the number outside. Guys, you can look at example 2 already if you want to. Take it down. You can try that example out and put your answers on the page and keep Indy company. But we're not going to do example 2 right now. I want you to try it at home, and we're going to look at example 1. All right, so applying the distributive law, we're going to multiply the 3 to every term inside the bracket. All right, so 3 times x. Then we're going to say positive 3 times positive 2 is going to give me positive 3 times 2y. And then positive 3 times positive 3 is going to give me positive 3 times 3. All right? 3 times x is just 3x. Plus 3 times 2y is simply 3 times 2 is 6. And then y. And then 3 times 3 is just 9. Okay, so we expand that bracket and we get 3x plus 6y plus 9. Now, for those of you who have tried example 2 at home, remember, just simply because the 6 is behind the bracket, it's still attached by multiplication. So we still do exactly the same thing. As I said, I'm not going to do the whole answer for you, but you're simply going to multiply the 6 by every term. You're going to distribute the 6 into the bracket. So you multiply by every term inside the bracket. If you guys did it, the answer you should have got is 6a minus 6b plus 18. Okay, we're going to move on. All right. And then this, some of you will remember, where you multiply a binomial, which means 2 terms, by another 2 terms. So we're multiplying a binomial in one bracket by a binomial in another bracket. We're going to do it the long way, and the reason for that, using distributive law. So we're going to multiply each term in the first bracket by each term in the second bracket. But the reason I want to show you guys the long way, and I know a lot of you already know the quicker way, but the reason we're going to show you the long way is that no matter how many brackets you multiply together, the distributive law always applies. So yes, a lot of you do two terms by 2 terms the quick way, but then as soon as we give you 2 terms by 3 terms, you start getting confused. And the reason is that a lot of people don't realize that you simply have to use distributive law no matter how many brackets you have. So I'll show you the quick way, but I also want you guys to concentrate on using distributive law because it helps you no matter how many terms there are in the different brackets. Okay, so we're given 2x plus y times x minus 2y. The example's already written out for us, so I'm simply going to go through it with you. Okay, we're going to times every term in the first bracket by every term in the second bracket. So if you follow me, for the first term, we're going to say 2x multiplied by the first term in the second bracket. We're going to get 2x times x. Then we're going to say 2x times the second term in the second bracket. Now guys, notice what we've done here with the signs. We've kept it as a positive something, positive 1 that's going to be times by something, all right? And the reason we did this is you've got to be careful with your signs. And a lot of you will just be going positive times a minus is a minus. If you can see it that quick way, you can do it, but remember to be very, very careful with your signs. That's one thing that a lot of people do, is they make lots of careless mistakes with products. Okay, so we're going to say keep the positive sign in front, because that's not going to, if we say positive times any sign, remember it's not going to change. So we'll keep the positive between the two brackets, positive 1, and we're going to say 2x, which is the first term, multiplied by the second term in the second bracket, and the second term is minus 2y. So 2x times negative 2y. All right? Then we're going to multiply the second term by every term inside the brackets, inside the second bracket. So we distributed the first term into the second bracket. Now we're distributing the second term in the first bracket by everything inside the second bracket. So positive y times positive x is just going to give me positive y times x. And then we're going to say positive, keeping the sign of the y times the second term, which is negative 2y. All right, important to use brackets there because it is going to affect your signs. All right, so we've multiplied each term by every term in the second bracket. So let's have a look. 2x times 2x gives me 2 times 1 is 2. X times x is x squared. Now remember, if you don't know where that power is coming from, it's your exponents from grade 9. If you have x times x, okay, remember the powers here are 1, okay, and remember your rule, when you multiply with the same base, you add the powers, so it's going to be keeping the x, keep the base, and you add your powers. 1 plus 1 will give me 2, so that's where that power of the x comes from, okay, so 2x times x is 2x squared. Now with the next one, we've got to be careful, multiply your signs as well. Positive 2 times negative 2 is negative 4, and then x times y is xy. Positive y times x is just going to be yx, and then the last one, we've got y times negative 2y. Negative 2 times 1, remember there's always an invisible 1 where there's no coefficients given. Minus 2 times 1 is minus 2. And y times y, using again your laws for exponents, y times y is y squared. Okay, let's simplify that further. 2x squared, we just bring it down. Now we've got to be careful with the signs. Positive 1, remember there's always an invisible 1 when there's no coefficient given. Positive 1 times negative 4 is going to give me negative 4xy. Positive y times x is just going to give me positive yx. We've written it here as xy, but remember that's perfectly acceptable. It's exactly the same as yx, and the reason is we showed you the commutative law before. Xy and yx are exactly the same because they're multiplied. Positive 1 times negative 2. 1 times negative 2 is going to give me negative 2, and then we bring the y squared through because it's y squared times 1, which is just y squared. Okay. Now, you get to that point, you've got to look at it and say, wow, is there anything else I can do? And yes, you can, because if you look at it, and by rewriting yx as xy, hopefully it's even clearer to you guys, you have like terms. So remember, when you have like terms, you need to simplify by adding your like terms. All right. So 2x squared, we simply bring down, minus 2y squared, we bring down. But look at the middle terms. We've got minus 4xy plus 1xy. Minus 4 plus 1 is negative 3xy. So we could add those together because we have like terms. All right. So guys, we went through that in quite a lot of detail simply because, as I said before, you need to remember that when we get into tougher examples like the next one we're going to do, which is timesing a binomial by a trinomial. So remember, binomial is like a bicycle, 2 wheels. A binomial has 2 terms. Trinomial is like a tricycle that has 3 wheels. Trinomial means 3 terms. So we're multiplying 2 terms by 3 terms. Okay. Using the distributive law, I'm going to go slightly quicker because we went through the previous one in quite a lot of detail. All right, so we're going to multiply each term from the first bracket by every term in the second bracket. Okay, so I'm going to take the 2x, multiply it to the x squared. I'm going to take the 2x, times it to the minus 2x, and then we're going to times it to the 1. Then we're going to do exactly the same thing to the minus 3. We're going to times it to the x squared, the minus 2x, and the positive 1. All right, so let's have a look. So our first term is going to be 2x times x squared. The next one we're going to have plus 2x times negative 2x. Then we're going to say 2x times just 1 from the second bracket. Then we're multiplying the second term. We're going to get minus 3 times x squared. Remember, we're taking the sign of the 3, so it's negative outside there. Negative 3 times x squared. And then we've got, again, negative, and then we're going to say 3 times negative 2x. And then once again, negative times 3 times 1. All right, so let's have a look what that simplifies to. The first bracket, 2x times x squared gives us 2x cubed. Remember, again from your exponents, x to the power of 1 times x to the power of 2 is x to the power of 3. All right, the next term, be careful, you've got to multiply your signs as well. A plus times a minus is a minus. 2 times 2 is 4, and x to the power of 1 times x to the power of 1 is x squared. All right, the next term, positive 2x times 1 will just give us positive 2x. Minus 3 times x squared will just give us minus 3x squared. The next bracket, careful with your signs, a minus. We've got a minus out there and a minus inside here. And a minus times a minus is a plus. Hence, you see that sign changing. 3 times 2x is just 6x. And then minus 3 times positive 1 is just going to give us minus 3. All right, so now let's have a look, guys. Do we have any like terms? So when you get to the step after you've times everything out, don't just stop. You need to look at your question and say, okay, well, hang on. Is there anything else we can do? Can we make it any simpler? If you have a look, we've got 2 terms in x squared. Then we've got 2 terms in x, which means we can add those terms together. Those are like terms. All right, so we bring the 2x cubed down, minus 4x squared, minus 3x squared, those are like terms. Minus 4 minus 3 is minus 7, and because they're like terms, obviously because of the x squared, it's going to be minus 7x squared. All right, positive 2x plus 6x, again, like terms, they're both in terms of x. So 2x plus 6x is going to give me plus 8x minus 3, we just simply bring down. Okay, so before we go on to the questions, I'm going to go to Indiana, see if she wants to take a break or see if you guys have any questions.
Well, it depends on whether you want to take a break, but there are amazing things happening on the page, and I just have to applaud the mindsetters. For example, Matapelo, she asked a question: what happens when you have 2 sets of brackets and a number in front of the brackets? Now, what the fantastic thing is that Natasha might not even have to answer, because we've got Fabian Palmer and we've got Oscar Corza, who has actually helped this mindset on the page, and this is something that I really want to get into, like drill into you guys for this year. This community is not just for us, it's for you. Facebook.com/learn extra is a community of mindsetters helping each other out. And we've seen it time and time again where mindsetters are helping each other out on the Facebook page and on Twitter, and it is so, so incredible. So Natasha, shall we take a break and come back? I think so. It is very hot in Joburg, guys. Let us know what the weather's like near you. Hope you're enjoying the show, and we'll see you now after the break. Welcome back, guys. I can't believe that this is our first show of the year, grade 10 maths. We've been having such an amazing time, but now, guys, I need your help. If you have any teachers out there that you know that want to help us develop content, then what they need to do is email content@mindset.co.za. So please give this message to your teachers. I will post it onto the page so you can pass it on. We need help with content. So now, let me have a look. We've got McDonaldson Taylor says, this is so easy. He's thinking of being a mathematician. This is fantastic. This means that they are all understanding. It's good basic skills to have, and I'm not going to take any more time from your lesson. So, Natasha, up to you.
Okay, thanks so much, India, and I'm glad you guys are finding it easy. It is an easy part of the syllabus, but such an important part, because as I said before, a lot of times because people don't understand, or pupils don't understand distributive law, they get confused when there's lots and lots of brackets. So we're quickly going to fly through the rest of distributive law, binomial by binomial, monomial by binomial, and a binomial by trinomial. Hopefully you guys remember what all those binomials, monomials, and trinomials means, but we'll remind you now. And guys, what I'm going to do with these is you'll see there's two parts to the questions. There's A and B, and I'm simply going to do either the A part or the B part, and it's going to be up to you to do the other one. Okay, in this example, when they say simplify the following expressions by expanding, I'm going to look at B, simply because we haven't done an example with the number behind the brackets. Okay, we've always done them so far with the number in front, so let's look at what happens when the number is behind the bracket or behind the binomial. So here we're looking at a binomial, 2 terms, by a monomial, 1 term. Okay, so remember the rule stays exactly the same whether the number's in front or the number's behind the bracket. We're going to times the number by every term inside the brackets. Okay, so, and I'm going to fly through this because I think a lot of you guys have the gist of it now. Minus 6 times positive 2. Remember to multiply your signs first. A minus times a plus will give us a minus, and 6 times 2 is 12. All right, then we're going to multiply the negative 6 by the negative 5p, multiplying your signs first. Minus times a minus is a plus. 6 times 5 is, whoopsie, that pen is going a bit wonky, and it was behaving for the first time. So minus times a minus is a plus. 6 times 5 is 30. 6 times 5p is 30p. All right, so as I said, guys, flying through these because I can see from the page and the comments that you guys really understand this section. Okay, so for the next one, we are multiplying a binomial by a binomial, so that means 2 terms by 2 terms. All right, I'm going to do the A part, and you guys can try the B parts at home. Okay, so we've got 2x minus 2 times 3x plus 8. Now, a lot of you guys would have learned to multiply this, not just by distributing each term, but you would have learned something called FOIL. Okay, and what FOIL tells you is the order in which you should multiply each of the terms. So first, outers, inners, last. Okay, and sometimes it's called the Kitty method and all sorts of other names, but remember your basic concept that you're using here is distributive law. You're multiplying every term in the first bracket by every term in the second bracket. Okay, so I'm going to multiply every term in the first bracket by every term in the second bracket. Okay, so let's have a look if we do that. So I've got 2x, positive 2x times positive 3x. 2 times 3 is going to give me 6. X times x is x squared, because remember we use our rule for exponents and we add the powers. All right, then we're going to multiply 2x by 3x. Oopsie, sorry guys, I just did that. 2x times 3x is going to give me 6x squared minus 2 times positive 8. Remember to multiply your signs. A minus times a plus is a negative. 2 times 8 is 16. And then we're going to times 2x by 8, and we're going to get 2 times 8, positive 2 times positive 8 is 16, and x times 1 is just x. And then lastly, minus 2 times positive 3x, a minus times a plus is a minus, 2 times 3 is 6, and x times 1 is just x. Now remember, when you get to this point, you need to look at your question and see, do we have like terms? Yes, we do. So we add the like terms. So I'm going to get 6x squared plus 16x minus 6x is plus 10x. And minus 16 will just bring down because there are no other terms to add that to. All right. Okay, so I hope you guys are all following and you're breezing through that section, which I think you will be doing. And Indy, do we have any questions?
Oh, I don't have any questions. I just want to say one more thing. I'm just so excited to be back here on air. This is our first show, Mindsetters, for the year, grade 10s, and it's especially for you. And I know that there are a whole bunch of you are tuning in not only on Facebook, facebook.com/learnextra, and on Twitter, but you are really, I can't believe how many guys are actually tuning in. I've got Sasanda who says she cannot wait for the grade 11 lesson. We've got, let me have a look here. Tendi says she's loving the lessons and she's really, really enjoying it. And there are no questions so far, but guys, let us know how your school year has gone. And even though that this is the first show of the year, we want to know how things have been going so far. So post that onto our page. And what I'm going to do is I'm going to send it straight back to Natasha.
All right. Okay, guys, so we're really going through this quite quickly now because a lot of you understand your basic concepts. We're now going to look at multiplying a trinomial by a binomial. So remember, that's 3 terms by 2 terms. I'm going to have a look at A, and you guys can try B at home. All right. So remember, the concept is exactly the same. You're multiplying every term in the one bracket by every term in the other bracket. So we're going to go from the binomial, we're going to times. It doesn't really matter. I mean, if you wanted to, you could start with every term in the first bracket. I prefer to times the smaller bracket out. So I'll distribute from the smaller bracket, but it really doesn't matter because remember, we use the associative law, so it doesn't matter which order you do it in. But I'm going to say 5y times every term in the first bracket, and then minus 12 times every term in the first bracket. And we're going to go through it quickly. So if I say positive 5y times minus 2y squared, I'm going to get positive times a minus is negative. 5 times 2 is 10. We've got y squared times y. So the only thing that could trick you up here a little bit is your exponents. Remember, when there's no power written, the power is always 1. So if I say y to the power of 1 times y squared, keep your base, add your powers. So y squared times y to the power of 1, 2 plus 1 is 3. Okay, so I'm going to get minus 10y cubed as my first term. Then I'm going to say positive 5y times negative 4y plus times a minus is minus 5 times 4 is 20. And y times y is y squared, again using your laws for exponents. And then we're going to go positive 5y times positive 11. Positive times a positive is a positive. 5 times 11 is 55. And y times 1 is just y. Okay, so those are the terms we get from just the 5y being multiplied into the bracket. Now we need to multiply the negative 12 into the bracket. Okay, so let's have a look. A negative 12 times negative 2y squared. Remember to multiply your signs. Minus times a minus is a plus. 12 times 2 is 24. And y squared. So y squared times 1 is just y squared. Minus times a minus is a plus. 12 times 4 is 48. Y times 1 is just y. And then minus 12 times positive 11. Now, I do think I can do this in my head, but I'm going to double check on my calculator. Plus times a minus is a minus, and I think your answer is 132. But let's have a quick look, because we don't want to get things wrong so early in the year. 12 times 11, 132. Okay, so we're safe. All right, so that is the multiplication of the brackets all done. multiply the trinomial by the binomial, we get this expression. Remember, when you get to this point, you're not done. You still need to add your like terms. So you look at your expression, see what like terms you have. You can see that you've got 2 terms in y squared, and you've got 2 terms in y. So the minus 10y cubed and the negative 132 are simply going to be brought down, but you need to add your like terms. Okay, so that one, and minus 20y squared and positive 24y squared. So minus 20y squared plus 24y squared will give me positive 4y squared. And then positive 48y plus 55y. Okay, let's do that on our calculator. So we've got 48 plus 55. And we get 103. Okay, so 103y as our third term. Okay, guys, so that's the answer to your simplifying of a binomial times a trinomial. Now, we are going to look at factors. We're not going to be able to get through all of factorizing like I had hoped, but we're going to try and touch on some of the basic concepts like taking out a highest common factor, and let's just see how far we get. Okay, so moving on, we're going to look at factorizing. Now remember, most importantly, factorizing is the reverse of expanding or distributing or finding the products, okay? And there are lots of different ways that we can factorize that we are going to look at, all right? But what I want to show you is, say you had this bracket 5x times x plus 2y. If you were asked to find the product, you would multiply that into the brackets and you'd get 5x squared plus 10yx. Now what we're doing with factorizing is we're starting at that point and we want to know what this was. So we want to know what numbers were outside, what numbers were inside the brackets, how many brackets were there, so that we finally get to that kind of answer. Okay, so we're starting here and we want to get back to there. Okay. So the most common or the simplest form of factorizing is taking out a highest common factor. And guys, remember to always do this first before you attempt any other kind of factorizing. I find a lot of times people get into really complicated messes, and it's because they haven't done that basic step of taking out a highest common factor. If you don't take out your highest common factor, sometimes you'll end up with this really long mess, when if you had just taken out the factor, it would have been much, much easier. Okay, so highest common factor. Remember, what you're looking for is you're looking for a number that's common to both terms. And we're looking for the highest common number to both terms. All right, so if we look at 5 and 10, we're going to look at the variables and the numbers separately, just so that you guys get back into it and remember. All right? If you're looking at 5 and 10, what is the highest common factor that will divide into both of these? And your answer, hopefully you guys can see it, is 5. 5 goes into itself once, and 5 goes into 10 twice. So the factors of 10, 5 times 2, and then obviously there's 1 times 10, but we know that 5 goes into 10 2 times, 5 goes into itself once, therefore 5 is the highest common factor between the numbers 5 and 10. So therefore, my number when I'm taking out a highest common factor is going to be the number 5. Now, if you look at x squared and yx, so we've got x squared. Remember, x squared simply means x times x, and yx simply means y times x. So the highest common factor that will divide into both of these terms is, you can see it there, it's x. X will divide into x squared, x times, and then x divides into yx, y times. So therefore, the highest common factor between the x squared and the yx is x. All right, now if we combine it, the highest common factor between these two terms will be 5x. All right, remember when you take out a highest common factor, you're dividing every single term by the factor. So we're going to say 5x squared divided by 5x, and we get 5 divided by 5 is just 1. X squared divided by x is just x. So that's the first term in our bracket. All right, and then we're going to do the same thing with the 10yx. 10 divided by 5 is 2. Yx divided by x, remember that's the factor you took out. The x's would cancel and you just get y. All right, so 5x into x plus 2y is the factorized form of, if you were given the product, 5x squared plus 10yx. The factorized form is 5x times x plus 2y. So you end up with a monomial times a binomial. Now, guys, you would have seen at school that you do lots of other types of factorizing. We do a lot of different types of factorizing, as I said. So we looked at highest common factor, but you guys would have also seen difference of two squares. You would have seen trinomials, grouping, and that kind of thing. And in your notes, you can try all of these questions and all of these examples, and send through any queries and that you have to us. But we're going to try and just see how much of time we have and what we can get through. Hopefully, I can do difference of two squares with you guys if Indy tells me that we've got enough time.
We've literally got 2 minutes. Can it be done in 2 minutes?
No.
Mindsetters? No. 1.5. What can we do? Is there anything we can do in 2 minutes?
We can do another taking out a common factor.
That's okay. Let's do that. Yeah.
Okay, guys, I really don't want to rush through difference of two squares with you guys. Remember, the most important thing with difference of two squares is there is a minus separating those terms. But I don't want to rush through that. Let's rather look at another taking out a highest common factor, and we'll look at maybe something slightly longer. All right? All right, well, let's quickly go back here. And I am just looking to see if I have any examples already done out for you guys. All right, so I'm going to take one that we've done where we've expanded it, and I want to show you that when we actually factorize it, we get back to the same answer. So if we look at this example we did before, minus 10y cubed plus 4y squared plus 103y minus 132. So we've got to have a look and see, is there any common factors? Okay, I'm going to actually split this up and just because we are running out of time, I don't want you guys to lose out on any step. Okay, let's have a look at something like this. All right, so we've got minus 10y cubed plus 4y squared plus 8y. Okay, now remember we're looking for the highest common factor. So we want the highest number that will go into 10, 4, and 8. And then we also want the highest letter or the highest variable that will go into y cubed, y squared, and y. Now if you look at 10, remember we can write the factors of 10. Okay, I know it is negative. We're not going to ignore the negative when we factorize, but just for our purposes now we are. 10 will be 5 times 2. All right. 4 is the same as, well, 10 is 1 times 5 times 2. We're going to ignore the 1 for now. 4 is 2 times 2. And 8 is 4 times 2. Okay, and I'm just taking the factors that I know will work. We can see the common factor that will go into all three numbers is the 2. 2 divides into 10, 2 divides into 4, and 2 divides into 8. So therefore, my highest common number that divides into all of these numbers is 2. All right, so if we divide through, remember we're dividing through by the factor 2. If we look at the letters y cubed, y squared, and y is the letter that is common to each of them. So therefore, very quickly now, dividing by a factor of 2y, minus divided by a plus is a minus, 10 divided by 2 is 5, y cubed divided by y is y squared, positive 4 divided by 2 is 2, y squared divided by y is y, positive 8 divided by 2 is positive 4, and y divided by y is 1. Okay, so we simply get 4 as our last term. So that was just a very, very quick example for you guys, just to practice a little bit of HCF. But remember, you've got the examples with difference of squares, trinomials, and sum and difference of cubes that you can try at home.
Okay, bye everyone. Thank you so much for tuning in. Jabulile said, I'm so enjoying the lesson. It's so easy. She's going to pass with flying colors. All of the grade 11s that are posting onto our page, don't forget that you are up next. Grade 10s, you've been fantastic. Thank you so much for getting the show off to a banging start. See you next week. Same time, same place. Bye.